Okay, here's a video talking about factoring, common factors and greatest common factors, a little bit of review, and also talking about how it applies to variables as well. So for factoring, we know how to factor. We can factor using something like a tree. We can say 12 is, I don't know, 3 times 4, 4 is 2 times 2. We can get our prime factors that way. 3 times 2 times 2 is 12. We could also, if we're ignoring prime factors, just factor. We could say 12 is 1 times 12. We could say it's 2 times 6 or 3 times 4. But it's also important to remember that we could do something like -1 and -12, or -2 and -6. Put brackets around these guys here. Or -3 and -4, because those answers will all still be 12. So we could have a pair of positive integers or a pair of negative ones, and we still get the same result. This is going to be something to keep in mind, this fact that we can do negatives or positives as we go through this 4th unit of polynomials. Similarly for 81, we could say it's 9 times 9, or we could even say -9 times -9. -9 times -9, we could say, or break our 9s into 3s, we could say it's 3 times 3 times 3 times 3, or 3 times 3 times -3 and -3, or -3, -3, all 4 of them negative. As long as we got pairs, we end up with a positive result. So all of those are options. All positive 3s, all -3s, or any combination with 2 negatives will still get us our end or our initial result of 81. Something really simple like 7x here, there's only one way really to do this, except for there's 2. We could say this is 7 times x, or -7 and -x. Both of those will get us 7x. Something like 12x squared, I'm going to do in kind of an odd little tree here. I'm going to say that's 12 times x squared. 12, I'll say, I don't know, 3 times 4. 4, I could say 2 times 2. X squared, I could say is x times x. So I could say that, in the end, 3 times 2 times 2 times x is 12x squared. Or I could throw negatives in any pair or any pair of pairs and end up with still my positive result like I had. So remember that negatives and positives are both options, and it's easy to forget about the negative options, but they still exist. For something like 6ab squared, I could say that this is 6 times ab squared. 6 I could say is 2 times 3. ab squared is a times b squared, and b squared is just made out of b's. So my factors here, I could say 2 times 3 times a times b, that's the prime factors. Or I could say something as simple as like it's 6 times ab squared. Those are factors. 6 and ab squared are factors. Or 6 times a times b squared. Those are all factors. Or I could say 2 times 3. I've got lots of ways to build these numbers, except for that one. And that lots of ways to build the numbers is powerful because it gives us lots of options, but it's also tricky because there's lots of things to check. For common factors, the question is what number can divide all of the terms? So for common factors 7, 63, and 343, I can divide these all by 7. 7 by 7 is 1, 63 by 7 is 9, and 343 by 7 is 49. So they all divide by 7. This is a common factor. 18, 324, and 729, I could divide these all by 9. 18 by 9 is 2. 324 by 9 is 36, and 729 by 9 is 81. So 9 is a common factor. Or here, x, 2x, and xy, I can divide these all by x. So if I divide these all by x by x is 1, 2x by x is 2, xy by x is just y. So x divides all 3 of these bits nicely. So x is a common factor. For our common factors, we need something that when we divide, we get an integer. So a positive or negative kind of whole number. No decimals or no fractions, just a nice, something like a 2 or a 49 or whatever. Greatest common factor is very similar to just common factor, but just acknowledging that there's more than one possible common factor for many groups of terms. So here 14, 70, and 112, I could divide these all by 2. They're all even numbers. I could divide them all by 7. 2 is a factor, 7 is a factor of all of these three, but I could also divide all three by 14. 14 by 14 is 1, 70 by 14 is 5, and 112 by 14 is 8. So 14 is also a factor, just like 2 was and 7 was, but this is the biggest one, the greatest common factor. Similarly, for 27, 135, and 81, I could divide them all by 3. That's a factor. I could divide them all by 9. That's another factor. But the greatest common factor between these all is 27. So 7 by 27 is 1. 135 by 27 is 5. And 81 by 27 is 3. So 27 is the greatest common factor. Other factors included 3 and 9. So 3 and 9 are also factors, but they're not the greatest. They're smaller. So in this case, 2 and 7 were also factors. For our last one here, 6ab, 24a squared, and 30ab to the fourth, I could divide these all by 2. All of our coefficients are even. I could divide them all by 3. They're all divisible by 3. I could even divide them by something like 2a. They're all divisible by 2, and they're all divisible by a. But the biggest factor I could divide them by is 6a. 6ab divided by 6a is just b. 24a squared divided by 6a, is going to be 4a. And 30ab to the fourth, 30 by 6 is 5. A by a cancels out, and we've got b to the fourth left over. So 6a is the greatest common factor, but other factors included 2, 3, a. Those are all common factors between these three terms, but only 6a is the greatest of those.